Yeah, I'm really actually excited to start playing. No fear.
Start helping you.
All right, we've got the Galaxy set up here to show you the next part of this equation, which is setting up the radio. We're going to fine tune it and refine it. So what we're going to do is we are going to work on the travel adjust and or the endpoint adjustments if you have Futaba. Now, it is very important that you do not confuse rates with travel. Your rates on your radio for like the dual rates need to be set at 100% and leave them there. We are going to work exclusively with the endpoint adjustments. So at this point, we are going to completely deflect the flight control. And then we are going to adjust it up as far as it will go. And as you can see, it's reached its physical limit. And I'm going to back it off just a little bit.
So you're not binding.
So I'm not binding. And once we've done that, that same exercise is done on every single flying surface. We now go to full down elevator. And we do the same thing. We max it out and then back it up just a little bit so we're not binding the surface. And now this surface is set.
Done. Okay, so I get it. I see what you've done, Michael. I've just done the ailerons and you've already done the elevator and the rudder. So that's our travel address part. Where do the rates come in? What happens next?
That's a really good question. The 100% associated with rates isn't a valid number until you establish what 100% is.
100% of what?
Right, so once you set that travel adjust, and the travel adjust in this case was at 123 before it hit the top. Now that becomes our 100%. And now when we want to change the rate and we want to drop the, you'll see the elevator on low rates is at only 30%. Well, that's 30% of 100%.
Got it. So you're 100, so now what we've done is we've set those limits. So 100% is whatever it is, it's however far that travel is. So what you're saying is that rate now becomes a ratio where that's 100%, and if you set your rate at 30%, it's 30% of whatever you decided was 100%.
Exactly. Like on a jet, you know, in this one here, it's got 3 inches of travel. On a jet, it might only be a ½ inch of travel.
But that's still 100%.
Exactly.
Got it. Very cool.
As long as it stays free.
Nice.
Let it go up high.
What I'm going to explain now is something a lot of people really don't understand, and that is exponential. With 3D planes, all the top pilots use a pretty fair amount of exponential on most of the surfaces, and there's a very simple explanation for it. If you check the elevator on this, if I deflect the elevator this much at a nominal rate of speed, this plane will do a 10-foot loop. Like this, it's a tremendous amount of throw. So what happens is if we don't use exponential, very little bit of movement on the stick will cause a very violent extreme reaction, especially when the plane is flying 20 miles an hour and above. I mean, it'll be very uncontrollable and it will feel very, very twitchy. So what we want to do is we want to make low rates, which in this case is about this much travel. High rates is that much. We want to make high rates feel just like low rates. Because most of the flying that you do when the plane is going at a nominal rate of speed is all done in the center of the stick. So exponential makes the center of the stick feel basically the same in both rates. What I'm going to do now is demonstrate the elevator with no exponential. And if you'll see, the stick at very little has the deflection very high, and then it moves very linear from top to bottom. You see, it's direct correlation.
Where the stick is where
Right.
the surface is.
Exactly. Now, when I take it to have, in this case, 68% of expo, if you watch as the surface is being deflected, the stick comes down. You see how far I'm going, and it's barely moved. Now, look at the very end of it. The last eighth of an inch, the thing travels all the way to the end. See? Travels 2 inches in a quarter of an inch.
Your maximum throw is something like that.
Exactly.
That's all you got, because at 150 miles an hour, that's a lose.
Yes,
or a roll.
Exactly. So the fact is, there's 2 configurations every 3D airplane needs to fly on. And the reason you really need low rates is if you want to fly any straight line maneuvers or basic sport flying, you don't need 45 degrees of deflection. It's just pointless. All right, finally, we're going to talk about CG.
Ooh.
It's really the last setup part.
So everybody tells me for 3D that we move our CG back, that we want our planes more tail heavy. Is that correct?
No.
Okay.
Okay, so what is correct?
But yeah.
All right.
Thank you.
Really?
What is correct, says Jose?
3D needs a balanced airplane. And there's some really good reasons why it needs to be balanced. If this plane is nose heavy, you compromise the sensitivity and effect of the flight surfaces. And if you have it tail heavy, although it will make it maybe hang on its tail a little bit better, the further back you go, the more erratic the plane becomes.
Yes.
And as you're trying to fly anything straight and make it look good, it looks terrible. It is a colossally bad idea to make a 3D plane tail heavy.
Period.
Nose heavy, it will fly straight a little better, but it doesn't really 3D as well. It doesn't like to, tumble as well and other things. If that makes any sense.
Totally.
So what we're shooting for is a perfectly balanced airplane. And finally, the most important part of balance is this. And it's my pet peeve in this hobby, and I explain it to at least 3 people a week, that they will take a gigantic motor and say, man, I want performance. So they take a 2-pound motor and they put it on a 1-pound airplane. And they go, well, I can balance it. I just have to put an extra half a pound in the tail. Well, technically, it's balanced only when it's level. And as soon as it goes a little towards the nose, now it's very hard to get the nose back up again. It's fighting it because it's very nose heavy. It's got a 10-pound motor on the front. Same thing goes this way. The plane will never actually perform properly unless you have a good balance. So yeah, we do need a nice 2-to-1 thrust to weight ratio, or 1.5 to 1 at the very, very least. But if you put too big a motor on it, you will throw the entire plane off balance because you are putting all of the weight at the very tip of the aircraft. And something's got to give. You're going to have to add weight to the tail, otherwise it won't fly straight. Make sense?
Sure does, and I know kind of an aviation rule of thumb is adding weight for the sake of adding weight, whether you're trying to achieve balance or whatever, is kind of always a bad thing. Right? I mean, we're trying to keep these planes as light as humanly possible.
Exactly. My goal is always light, and everybody I talk to who asks me for recommendations, I keep saying the same thing over and over. Keep it light.
You said it to me many times as I was building these, and it's great.
Keep it light.
the door.